Hello, and welcome to another live from this series. I think this is the 15th live from the series where we are studying the algorithm and data structures course on Freecodecamp. Now, just for any new people that might be watching this, I have recorded all the past lives going from the beginning of the course. So if you're new, I have them all in a playlist with the live events, so you can watch them from the beginning if you'd like that. Now I'm going to change this screen to where I share my screen before I forget, because it did happen one time that I went through all the live without sharing my screen. And we're going to get started from where we left off last time. We were somewhere in the middle of the object-oriented programming module, so we're gonna get started from there. But like I said, if you're new and you want to watch from the beginning, you can find all the videos in the live events playlist. Alright, so here with add lesson, change the prototype to a new object. And they say up until now you have been adding properties to the prototype individually like this. I think we may have done this lesson in the last live, but if it doesn't really matter, we can just repeat it. So you would add it like that to the prototype. This becomes tedious after more than a few properties, but prototype it equal function, and so it basically shows how it became tedious if you do it too many times. A more efficient way is to set the prototype to a new object that already contains the properties. This way the properties are added all at once. So basically you're just saying prototype and you give it a new object with all these properties. And here is a add the property num legs and the two methods it and describe to the prototype of dog by setting the prototype to a new object. And I think we already did that in the last lesson. Basically we're just saying dog prototype equal object, and we put all these new things here. Let's run the tests and let's go to the next challenge. Alright, so remember to set the constructor property when changing the prototype. There is one crucial side effect of manually setting the prototype to a new object. It erases the constructor property. This property can be used to check which constructor function created the instance, but since the property has been overwritten, so basically when you're giving to the prototype, you're giving a new object, that property does not exist anymore. So if you're saying duck constructor equal bird, duck constructor equal object, you will get false for this. For this you will get true, and duck instance of birds is gonna be true. To fix this, whenever a prototype is manually set to a new object, remember to define the constructor property. So you need to tell him after you change the prototype to an object, you have to tell him which was the constructor of that whatever. So basically when you're saying something like bird prototype equals an object with different properties, you have to tell it here in this object that the constructor is the bird, which is a weird. They could have made it automatically, I guess, but I don't know. Here it says define the constructor property on the dog prototype. So the way we change the prototype here, to make sure that we don't override the constructor, we're just saying the constructor here is dog. So basically this is the constructor, right? And I'm just gonna check from time to time to see if anybody says anything. So if you have any comments, you can put them on in the chat. I just love coffee. Alright. Understand where an object's prototype comes from. Just like people inherit genes from their parents, an object inherits its prototype directly from the constructor function that created it. For example, here the bird constructor creates the duck object. So you have this constructor and you create an object by using new bird of Donald. Now here duck inherits its prototype from the bird constructor function. You can show this relationship with its prototype of method. So you can say bird prototype is prototype of duck, and this will return true because duck is a prototype is the because bird is the prototype of duck, from what I understand. Use is prototype to check the prototype of beagle. So basically you wanna say dog prototype is prototype of beagle, and this should return true because it was created by using new dog. Alright. Now it's good to remember this because they are using some kind of programming in my style of programming, the way I usually use. I haven't used too much object oriented programming, but it's good to know all these things because sometimes you may need it. Alright, I'm gonna say ask me later. Here, understand the prototype chain. All objects in JavaScript, with a few exceptions, have a prototype. Also, an object's prototype itself is an object. So you have this constructor, and here type of bird prototype is an object. Then a prototype can have its own prototype, and of course, because the prototype is an object. In this case, the prototype of bird prototype is object prototype because it's basically an object. So if you're saying just object prototype is prototype of bird prototype, then this is true. How is this useful? You may recall the hasOnProperty method from a previous challenge. Let duck equals new bird of Donald and then duck hasOnProperty name. The hasOnProperty method is defined in object prototype, which can be accessed by bird prototype, which can be accessed by duck. This is an example of the prototype chain. In this prototype chain, bird is the supertype for duck, while duck is the subtype. Object is a supertype for both bird and duck. Object is a supertype for all objects in JavaScript. Therefore, any object can use the hasOnProperty method. So here it says modify the code to show the correct prototype chain. So here it says dog, well here we have to change, and here we basically have to say object is prototype of dog prototype because dog prototype is an object, so object is prototype of dog prototype. I know it's like blah 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 blah. What is it saying here? I'm getting an error. Your code should show that object prototype is the prototype of dog prototype. Okay, isn't this what I said? Is prototype. Oh, yeah, I basically forgot one thing. You have to say object prototype is prototype of. Okay, let's run the tests. Hey, Provisual, the constructor, and basically I'm actually learning it now as well. If you can if you can watch the lesson from before, we were going through what is the constructor. But basically, if you have something like this, I'm going to show you. I do not know much about it because I'm not really using too much object-oriented programming. But basically, if you have you can have a constructor like this, right? Const, and let's say you want to exemplify a car, right? Const car equals, and you get this, and maybe you can you can pass it like a make, right? And then actually it has to be like this: function car of make. Wait, is it has to be like it? Yeah. So you have something like this, or maybe we can put it like this: const car, right, equal function, and here you can pass some things that you may want to use, right? Maybe the make of the car, and then you say this make equals make, stuff like that, right? And then const. So basically this is the constructor, which basically can construct new objects with this. You can construct new object with this function, right? So you can say const my car equals new car, and here you pass Ford, right? So now if I console log my car clear node code gs, you can see it's this object car with the make Ford. It basically creates a new object with these properties, and then you can change them, and you have different things like you can change its prototype, right, and stuff like that. But like I said, I don't know much about object-oriented programming. I'm basically learning it now as well, and then later on maybe I'll get more advanced with it. But mostly in my job I use functional programming with JavaScript. So yeah, hopefully that was enough that you wanted. Otherwise, I suggest maybe going on YouTube and looking for a more in-depth explanation. But also we're going to all of the stuff that you would need to know if you want to work with object-oriented programming. All right, and as you can see here, basically if you override the prototype, you have to tell it the constructor. So this is basically the constructor, is the function which creates objects, right? So here it says use inheritance so you don't repeat yourself. There's a principle in programming called don't repeat yourself, dry. The reason repeated code is a problem is because any change requires fixing code in multiple places. This usually means more work for programmers and more room for errors. Notice in the example below that the describe method is shared by bird and dog. So for example, you're saying here bird prototype is an object where you're saying the constructor is bird, and then you have describe here, and then dog prototype is like describe again. So here the describe method is repeated in two places, right? The code can be edited to follow the drive principle by creating a supertype or parent called animal. So you have the function animal, right? And then you say animal prototype constructor animal, and then you have the function described, right? Since animal includes the describe method, you can remove it from bird and dog. So you don't say in these prototypes anymore that you need the describe, right? So here it says the it method is repeated in both car cat and bear. Edit the code in the spirit of dry by moving the id method to the animal supertype. So as you can see here, we have a function cat like this. Then we have the cat prototype, which has the it, right? And then the same for the bear, you have same, right? So what you want to do is just move this function from this to here, right? And you don't need it here as well, right? You can just delete it. We're getting an error here, or inside a block. What it says: in strict mode, code function can only be declared at top level, or what's this? Oh, I'm doing I'm putting it in the wrong place. I was putting it in the function animal, which is just the constructor. I need to put this in the prototype, right? So you have this like this. And remember, this is, you put this it function method here because when you have created bear and cat, when you've created them, I don't really understand what they're doing here, because if you're doing this, then uh, then the cat and bear should have created with the animal constructor. So I guess they'll explain that in the next lessons, because to have this id method here and being able to use it here, then the bear and the cat should have been created using the animal constructor. Okay, let's go forward. Okay, so here say inherit behaviors from a supertype. In the previous challenge, you created a supertype called animal that defined behaviors shared by animals. So function animal, then you have animal prototype it equals function, right? This and the next challenge will cover how to reuse animals method inside bird and dog without defining them again. It uses a technique called inheritance. This challenge covers the first step: make an instance of the supertype or parent. You already know one way to create an instance of animal using the new operator. So we have something like this: new animal, like we showed before. There are some disadvantages when using this syntax for inheritance, which are too complex for the scope of this challenge. Instead, here's an alternative approach without those disadvantages. So we have let animal equals object create, and then you give the animal prototype, right? Object create of an object creates a new object and set obj as the new object's prototype. Okay, this is confusing. So object create of object creates a new object, so creates the object like animal and sets object as the new object's prototype. So basically is making the prototype of animal being this object, right? So the prototype of this is the animal prototype. So here recall that the property is like the recipe for recall that the prototype is like the recipe for creating an object. By setting the prototype of animal to be animal's prototype, you are effectively giving the animal instance the same recipe as any other instance of animal. So now if you say animal it, the instance of method here would return true. So yeah, because animal is an instance of animal because you have given it the same prototype. Here is a use object create to make two instances of animal named duck and beagle. So here we say object create, and here we want to give the animal prototype and same for here. Okay. Set the child's prototype to an instance of the parent. In the previous challenge, you saw the first step for inheriting behavior from the supertype or parent animal, making a new instance of animal. This challenge covers the next step. Set the prototype of the subtype of child, in this case bird, to be an instance of animal. So what you're saying is bird prototype equals to object create animal prototype. So basically you're making the prototype of bird being the same as of animal. Remember that a prototype is like the recipe for creating an object. In a way, the recipe for bird now includes all the key ingredients for animal. So once you have said this, then when you say let duck equals new bird of Donald, then you can actually say duck it, because now the prototype has that it method. Duck inherits all of animal's property, including the it method. So here it says modify the code so that instances of dog inherit from animal. So here what you want to say is dog prototype equals to object create, and you give it the animal prototype. So now all the instances of dog will inherit the methods from the animal prototype, right? Okay. Reset an inherited constructor property. When an object inherits its prototype from another object, it also inherits the supertype's constructor property. Here's an example. You have function bird, and when you say bird prototype equals object create animal prototype, then you say let duck equals to new bird, and then you try to access duck constructor, but duck and all instances of bird should show that they were constructed by bird and not animal. To do so, you can manually set bird's constructor property to the bird object. So you say bird prototype constructor equal bird, and then when you access duck constructor, you get bird. So here it says fix the code so duck constructor and beagle constructor return their respective constructors. So as you can see here, we have basically uh, give to these prototypes, or to inherit from the animal prototype. But now if we try to access the instances, when we make instances of bird and dog, if we access the constructor, then it will give us animal. So we have to basically reset the constructor, because it's the same as when we were giving to the prototype a new object. We had to redefine the constructor to being to being the constructor that it was before, because we don't want to override it. So now basically we have to reset it after we give it this prototype. It's not gonna have the proper constructor anymore, so you have to reset it. So you're gonna say something like this: bird prototype constructor equals bird, right? And then same bird prototype constructor, here you have dog, and you reset it to be dog, right? Okay. Okay, here add methods after inheritance. A constructor function that inherits its prototype objects from a supertype constructor function can still have its own methods in addition to inherited methods. For example, bird is a constructor that inherits its prototype from animal. So you have function animal, function bird, then you have bird prototype equals this, then you reset the constructor. Now, in addition to what is inherited from animal, you want to add behavior that is unique to the bird objects. Here, bird will get a fly function. Functions are added to a bird's prototype the same way as any constructor function. So you're just saying bird prototype fly equals function and so on, like we have learned a little bit before. Now instances of bird will have both eat and fly methods, right? Duck eat would display the string nom 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 in the console, and duck fly would display the string I'm flying. Here it says add all the necessary codes so the dog inherits object inherits from animal and the dog's prototype constructor is set to dog. Then add the bark method to the dog object so that Beagle can both eat and bark. The bark method should print woof to the console. So we have to basically add the constructor of the animal, right, to the dog. We have to make dog inherits the property from animal. So what we want to say is say dog prototype equals to object create, and we give it the animal prototype, right? Then we want to reset the constructor for dog, right? So we say dog prototype constructor equals dog, right? And then we want to add a method that's called bark, right? So we want to say dog prototype bark equals function and here you want to say console log woof, right? Woof. All right. Okay, here it says override inherited methods. In previous lesson, you learned that an object can inherit its behavior methods from another object by referencing its prototype object. So you have child object prototype equals this, right? What we learned before. Then the child object received its own method by chaining them onto its prototype, like this, right? It's possible to override an inherited method. It's done the same way, by adding a method to the child object's prototype using the same method name as the one to override. Here's an example of bird overriding the eat method inherited from animal. So we have this function, animal, this constructor with the eat method on the prototype. Then we have a function bird. We put the prototype to bird to animal, and then we can override actually that if method if we want, because there might be multiple methods and we want to inherit all of them, but we want to override one, so we can easily override it just by the same way we are creating one. It's the same as when you have an object with a property that are right there, and when you say object of name maybe equals to Marian, if it doesn't exist it creates it, but if it exists it just overrides it, right? If you have an instance let duck equals new bird and you call duck it, this is how JavaScript looks for the method duck's prototype chain. So it looks in the duck. Is it defined there in the it method in the duck? No. Then it looks into bird. Is it defined there? Yes. So it executes it and stops searching. It doesn't. If it didn't find it there, then it will go up the prototype, right? So it would go to animal and it would find it there. So it says it is also defined in animal, but JavaScript stops searching before reaching this level. It's the same if you know how scope works in JavaScript. Is this it works the same way. So basically, if you are if you have a function, right, and then inside that you have another function, and then inside that you have another function, right? When you're referencing a variable with a name, it first looks for that variable in the function that you're in. If it's not there, it looks outside that function in the function that's outside, right? If it doesn't find it there, it goes up and up. So it's the same here. Override the fly method for penguin so that it returns the string alas this is a flightless bird. So here we have the blah blah, and then we give it the prototype of birds to the penguin, right? And we override the constructor. Now we want to override the fly method. So we want to say penguin prototype fly equals function return alas this is a flightless bird. Okay, it says penguin. Okay. Use a mixin to add common behavior between unrelated objects. As you have seen, behavior is shared through inheritance. However, there are cases when inheritance is not the best solution. Inheritance does not work well for unrelated objects like bird and airplane. They can both fly, but a bird is not a type of airplane and vice versa. For unrelated objects, it is better to use mixins. A mixin allows other objects to use a collection of functions. So we have something like let fly mixin equals function of object, and then you're saying object fly equals function, right? So this is basically a fly mixin which you pass it an object, right? And it adds that method, the method fly, on that object, right? So the fly mixin takes any objects and gives it the fly method. So if you have these two objects, right, and you basically say fly mixin of bird and fly mixin of plane, you basically added that method of fly on both of these objects. Here bird and plane are passed into fly mixin, which then assigns the fly function to each object. Now bird and plane can both fly. Right? The console will display the string flying whoosh twice, once each for fly call. Note how the mixins allows for the same fly method to be reused by unrelated objects bird and plane. Here it says create a mixin named glide mixin that defines a method named glide. Then use the glide mixin to give both bird and boat the ability to glide. So we want to say const glide mixin equals function of object, because we're passing an object, and then we say object of glide equals function, and what should we say in the function? What did they say here? Console log glide, right? Maybe console log glide, right? And then you basically use this glide mixin, you call it with what? Mixin, you call it with bird, so you give it that ability, and then glide mixin of both, right? Let's run these tests. Alright, well, we're close to the finish of this module, and then we're going to get into functional programming, which is my favorite. And it's my favorite because I'm more used to it. I know I have to study more object-oriented programming because that's useful as well. But for me, functional programming is the best at the moment. Use closure to protect properties within an object from being modified externally, right? Because while you create the, like in the constructor, while you say this name equals name, you can actually modify modify the values of that objects from outside. Sometimes you would want to not being able to modify them from outside. So in the previous challenge, bird had a public property name. It is considered public because it can be accessed and changed outside the bird's definition. So you can say something like bird name equals Duffy, right? Therefore, any part of your code can easily change the name of bird to any value. Think about things like password and bank accounts being as easily changeable by any part of your code base. That could cause a lot of issues. The simple way to make this public property private is by creating a variable within the constructor function. This changes the scope of that variables to be within the constructor function versus available globally. This way, the variable can only be accessed and changed by methods also within the constructor function. So you're just saying function bird, and here you're saying let hatch egg equal 10, and then basically instead of saying this hatched egg equal 10, you have let hatched egg equals 10, and then you have a this get hatched account equal function, and it will return the hatched egg. So then you have let ducky equals new bird, you create a new instance, and then to get that value you just call this method and it returns it, right? Here get hash account is a privileged method because it has access to the private variable hashed egg. This is possible because hashed egg is declared in the same context as get hash egg count. In JavaScript, a function always has access to the context in which it is created. This is called closure. So here it says change how weight is declared in the bird function so it's a private variable. Then create a method getWeights that returns the value of weight 15. So instead of having something like this where if you create an instance of bird you would be able to change weight from outside, we're just gonna say let weight equals 15, and then you create a method, this get weight equals function, right? And that would return weight, right? So then you would be able to call, when you create an instance like of the bird, like bird equals new bird, right? Then you can say bird get the weight and call it, and you would get the weight, right? But you wouldn't be able to change it. All right. Understand the immediately invoked function expression, which is commonly called as if. A common pattern in JavaScript. It says a common pattern, but it's very weird because I don't think I ever really used it. A common pattern in JavaScript is to execute a function as soon as it is declared. So basically you create the function and you also call it like this. You put them between parentheses like this and you call it. This is an anonymous function expression that executes right away and outputs chirp chirp immediately. Note that the function has no name and is not stored in a variable. The two parentheses at the end of the function expression cause it to be immediately executed or invoked. This pattern is known as immediately invoked function expression, or IFI. So here it says divide the function make nest and remove its call, so instead it's an anonymous immediately invoked function expression. So we're gonna remove this, and what you want to do is put it between parentheses like this, and you don't need the name anymore, right? And then you just call it immediately, right? All right, I think this is the last lesson from here. So it says use an immediately invoked function to create a module. An immediately invoked function expression is often used to group related functionality into a single object or module. For example, an earlier challenge defined two mixins. So you have this mixin and this mixin. We can group this mixin into a module as follow. Let motion module equals, and you say a function, right, which returns glide mixin and fly mixin. So basically it returns an object. I'm trying to understand why would we say, why would we make this an immediately invoked function expression which returns an object instead of just putting it in an object, right? Note that you have an immediately invoked function expression that returns an object motion module. This returns object contains all of the mixing behavior as properties of the object. The advantage of the module pattern is that all the motion behaviors can be packaged into a single object that can be used by other parts of your code. Here's an example of using it. Motion module dot glide mixing duck glide. I still don't get it. To why do we have to make it an immediately invoked function expression which returns an object? Why can't we just say, okay, this is the object, right? I don't really get it. Alright, I don't know why you would do that really. Maybe I'm missing something. Create a module named fun module to wrap the two mixins, execute mixin, and sigmixing file module should return an object, right? So we can copy this and say const file module equals, and we're gonna do an immediately called function expression, and we're gonna say function, which is anonymous, and it's going to return an object with these things in it, these properties, right? And here it's comma, is it comma, how we call this, yeah, and then we call it, right? Where is my mistake? Return this okay, and here is not equal, is actually two dots like this. Okay, so basically we create an immediately invoked function expression which returns an object. Let's see what happens if I just put the object like this instead of let's just say this, right? I mean, it's still working. Why do we need an immediately invoked function expression? I don't get it. But yeah, anyway, I don't get it really. All right. Even though this is only 45 minutes in this session, I think I should stop here for now because we're getting into the functional programming from next time, and I'll probably do one of these sessions tomorrow, hopefully. If something doesn't come up, I'm going to get started with another live session tomorrow where we're doing some functional programming. Alright, I hope you learned something with me in this one, and if not tomorrow, then sometime soon I'll see you on the next one where we're starting with functional programming, which is going to be really fun. Alright, have a good day or evening wherever you are. Bye bye.